Hello everyone. In this lecture we will discuss forces on linear dielectrics. For this suppose this is a x-axis and this is y-axis, and here suppose these two, that is this and these, are the two parallel plate capacitor, and length of these parallel plate capacitors, suppose this is L, and suppose here we have a dielectric material which is partially introduced in between the parallel plate capacitor, and suppose this distance is x. Now here let W be the energy of the dielectric system. So if here suppose W be the energy of the system. Now here if we pull the dielectric out and infinitesimal distance dx, that is, if we pull the dielectric out and infinitesimal distance dx, then change in energy, this is equals to minus F into dx. So here F is the force and dx is the distance, infinitesimal distance dx. Here negative sign shows that the force is in the negative x direction. Further we can write F equals to minus dw by dx. Further, but the energy stored in the capacitor this is equals to W is equals to half C V square. This is a well-known relation, or we can write 1 over C V square. We multiply with C and divide by C, then we can write half C square V square over C square C. Okay, and this CV is equals to half Q square over C. Why it is so? Because CV is equals to Q. Okay, so here W is equals to Q square over C. So as per our question we require, so F is equals to, therefore F is equals to minus d by dx, and W is equals to 1 by 2 Q square over C. Suppose here Q is constant. So here Q is constant. Because Q is constant, so we can write minus Q square over 2 d by dx or C minus 1, or this is equals to minus Q square over 2, here minus C minus 2 dc by dx, or this is equals to Q square over 2C square dc over dx. Okay, so F is equals to Q square over 2C square dc by dx. Further, this Q square C square, this is equals to V square, because Q equals to CV. So we can write, so F is equals to Q square over 2C square dc over dx. Further, Q square over C square is equals to V square, so we can write 1 over 2 V square dc over dx. Why it is so? Because Q is equals to CV. So Q square over C square equals to V square here. So now F is equals to this. But in our case, the capacitance, that is C, this is equals to epsilon naught A over D epsilon RL minus psi E into X. So here epsilon naught is the permittivity of free space, epsilon R is the relative permittivity or dielectric constant, L is the length of the capacitors, chi E is the electric susceptibility, and X is the distance, which we discussed already. So as per equation, when we differentiate with respect to dx, so here variable quantity is this only, so we can write epsilon naught A over D, and here we have minus chi E. Okay, so when we substitute the value of dc by dx in this equation first, then we can write F equals to 1 by 2 V square into epsilon naught A over D minus chi E, or this is equals to minus epsilon naught A chi E over D, and here we have V square. So this is the expression for force on the dielectric system. Okay, thank you.